Okay, let's look at each of these situations. The top one, where I have A being a set consisting of 4 distinct points. I'm not bothering to give them names because I just want to sort of make a non-rigorous point here. And B consisting of apparently more than 4 points. And here we have a second situation in which A has a bunch of points, definitely more than 3, and B has only 3 points. Okay, and the question that I want to ask is, in the top case and the bottom case, is it possible to have a function map the left set to the right set in an injective way? So remember, function means any dot from the left side can only go to one dot from the right side. So if you see a dot on the left, there can be only one thing coming out of it. You cannot have 2 lines coming out of it. And injective means sort of the same thing but flipped around. For any dot on the right side, there's only one thing at most coming to it. There could be nothing coming to it, or there could be one line coming to it. Okay, so let's try to connect up the dots on the left here to the dots on the right here in such a way that it defines an injective function from A to B. So it's pretty easy. Just start connecting dots and just make sure that you don't send 2 dots to the same place. If you send 2 dots to the same place, then you would still have a function, but it would not necessarily be injective, or it would not be injective. Okay, so there we are. The answer is yes, we can in this situation. And you can view this kind of function as being a way of looking at the elements of A as though they were elements of B. So an injection like this sometimes is thought of as a way of viewing A as a subset of B. Even though A is not literally a subset of B, there's a certain subset of B that has 4 dots in it, just like A does. So when you have an injection, it's almost like you're saying that you have a subset. It's just that the dots might have different labels. They might be named different things. Okay, so you could think of this blob as sort of like a copy of A, with the dots having different names, and it's inside B. How about this one? Can we map A to B injectively? So I could start doing something pretty injective. Maybe I'll send this dot there, I'll send this dot there, and then I have only one choice where to send this dot, which is there, and I have no choices for where to send the remaining dots. I have to send them somewhere because I'm talking about functions with domain A. The question is, can I map the entire domain into the codomain injectively? Where can I send these? I have to send them to some places where I've already sent some dots before, right? So no matter how I connect things up, there's going to be dots that have multiple connections. So this kind of picture, if you think in terms of the way we've been representing functions as sets of pairs via these pictures, this picture definitely shows you a non-injective function, and I hope it at least feels like it was impossible to make it injective. And I hope it feels like the reason that it's impossible is that here there are more elements in A. There are too many for it to be possible. And here it was possible because there are fewer elements in A than in B. So if you believe those things, then you can think of the existence of an injection. So if there exists an F such that F maps A to B and F is injective, you can think of this as being a way of saying that A has fewer elements than B. So you can think of the existence of an injection from A to B as a way of saying A has fewer elements than B. the existence of an injection is a way to detect whether A has fewer elements than B. You can ask the same sort of question about surjections, and you'll be able to make a similar kind of observation. So let's set up an example for that. So say I've got this set with 3 things, and maybe this set with 2 things, A, B, and is surjection A to B possible? Yes, it's possible. Here's one. Definitely an injection is not possible. I must send 2 different things to the same thing, no matter what I do, but a surjection is possible. It's possible to get every dot on the right side. So in this situation, yes. However, let me reset this. If I had, let's say, the situation were reversed, I have 3 dots here, 2 dots here, then is a surjection possible? And no matter where I choose to send this dot, and no matter where I choose to send this dot, someone will get left behind over here and not be mapped to by anything in the domain. Now, you could try to connect another edge like this, and that would define a set of pairs, but it wouldn't be a function. When we talk about injections and surjections, we're talking about functions. So this is never allowed. So a surjection is not possible. Okay, so it seems like what caused it feels at least, like what caused a surjection not to be possible is that B has too many elements, more elements than A does. So maybe I can summarize this fact like this. So for injection to be possible, A has to have fewer elements than B. Or equal to. Right, we'll think of fewer as meaning fewer or equal to. If A had more elements than B, we saw that an injection doesn't seem to be possible. And for surjection to be possible, A must have more or equal. This is fewer or equal. This is more or equal elements than B. So this is just an observation based on diagrams with dots. It's not a proof. This is not a theorem. It's just what we feel is true from looking at the pictures. For an injection to be possible, let me put it this way, B has to have at least as many elements as A, and for a surjection to be possible, A has to have at least as many elements as B. So then, for a bijection to be possible, A has to have exactly the same number of elements as B. So you can think of, there exists a bijection as being a way of saying that A has as many elements as B. So the existence of a bijection is a way of detecting that A has as many elements as B. And here there have been no definitions, no theorems, no proofs. There's nothing here that you can use in any of your proofs, but this is just suggesting a definition that we're about to write down. We can define the phrase A has as many elements as B by this precise condition. There exists a bijection from A to B.